Unit 3, we're talking all about quadratics, and even more than just quadratics. We're going to talk about first factoring out greatest common factors from all kinds of polynomials. In the first example, we need to find the greatest common factor. We have two terms here. We have this first term, actually, you know what? Let me do it this way. We have, oh, lost my problem. We have a red term right here, and we have a blue term right next to it. So we have two terms, I can tell because they're separated by the plus sign. I need to first think about the coefficients, the 16 and the 32. What's the greatest common factor between 16 and 32? And the answer is 16. I could divide both of these by 16. That's the biggest number. Then we're going to look at the x variable. The red term has 5 x's, the blue term has 4 x's. The most they have in common is 4 x's. Finally, we look at the y variable. The red term has 3 y's and the blue term has 1 y, so the most y's they have in common is 1 y. You could think of dividing each term by this greatest common factor. When I do that, the first term I'm left with just x y squared. That's what's left for the red term. And for the blue term, I'm left with 2. The x's cancel out, the y's cancel out, and that's it for my blue term. So my final answer is 16x to the 4th y times the quantity xy squared plus 2. Now we have 3 terms. We need to factor using a greatest common factor. Well, 3, 4, and 5 do not have a greatest common factor other than 1. The first term has 5 x's, the second term has 4 x's, and the third term has 2 x's, so the greatest common factor is 2 x's, x squared. Dividing the first term by x squared, I'm left with 3x cubed. Dividing the second term by x squared, I'm left with 4x squared. And dividing the third term by x squared, I'm left with just negative 5. You can always check your answer by distributing. You should get back to the original problem if you've done it correctly. It suggests factoring with a difference of perfect squares. 36x squared is a perfect square. It's x squared. And 100 is a perfect square. It's 10 squared. And what we have here is the difference between the two. When that happens, we can use a formula says the first binomial is positive, the second one is negative here. I'm going to put a 6x and a 10. And I have now factored squares. Again, you can check it with Gauss method, but you will get back to the original problem. Here, we have a difference of perfect squares again. Q squared and 4 squared. Split them. Q and Q, it's a positive, one's a negative, 4 and 4, which would be C. Now we do not have a difference of perfect squares. We do not have a greatest common factor. We have a quadratic trinomial. And the rule is you take the leading coefficient here and multiply it by the 24. And then we make a list of factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 6 and 4, well, we already have that. And we're looking for terms that multiply to 24 and combine to negative 11. Well, if I'm trying to combine numbers to get a negative, they both have to be negative so that they can multiply to become positive. So I'm going to make them all negative. Notice negative 1 times negative 24 is still positive 24, but now they combine to negative 24, which isn't what I wanted. I want negative 11. Negative 2 and negative 12 do not combine, but negative 3 and negative 8 work. Which means, in order to factor this, I'm going to write x take away 3, x take away 8. If I FOIL or box this, I will get back to the original quadratic trinomial. This next problem kind of has some typos in it. There shouldn't be these absolute value bars, so let me get rid of those. Alright, we're trying to still come up with two numbers that multiply to 24 and combine to 10, which we know would be 6 and 4. So a plus 6, a plus 4 gives me this quadratic trinomial. Two numbers that multiply to give me 25 and combine to negative 10 would be x take away 5, x take away 5. And now it gets a little bit more interesting because our leading coefficient is no longer 1. 4 times negative 3 gives me negative 12. Numbers that multiply to negative 12 numbers on this list combine to give me positive 4. Well, these both combine to give me a 4, but this one gives me a positive 4. So the rule is you take this first term and rewrite it, but you don't need to make it squared anymore, just 4x. Then we're going to put the winning combination underneath them and reduce. Put them in lowest terms. For instance, that can become a 2 and a negative 1. I can divide both of those by 2 and get a 2 and a 3. So now I have 2x over negative 1, 2x over 3. And I drop those right into the parentheses, and I am factored. 2x take away 1, 2x plus 3. Number 9, which graph represents the function? Right, well, we are looking for a graph that opens up because the leading coefficient is 1, so we know we want it to open up. So I can eliminate B as an answer choice. It's not going to be B. Now we need to think about how this would look if we graph it. One option that would help would be to find the vertex of this. Vertex is going to be negative B over 2a, and then the function of negative b over 2a. If I take negative 2 over 2 times 1, negative 2 over 2 times 1 gives me negative 1. And then if I find f of negative 1, that would be 1 minus 2 minus 1, which equals 2. So I believe my vertex is at negative 1, negative 2, which would be right here, not here. C would work. How about D? D would not work. Negative 1, negative 2 would be down here. So I'm thinking it's going to be C. But another perfectly acceptable way of doing this would be to type this function into a graphing calculator or use Desmos, a graphing calculator software that's available to you on your computer at desmos.com. Let's try that. Let's try typing x squared plus 2x minus 1. Let me make sure I typed it correctly. X squared plus 2x minus 1. you can see that the vertex is indeed right here at -1, -2. It crosses at -2.4. It also crosses at 0.4. So my answer choice of C would work. That is the correct answer. Now we're going to solve quadratics. We can solve one of three ways: by graphing, by factoring, or by using the quadratic formula. This one is a pretty simple one to solve by factoring, but it's probably even easier if we type it into Desmos. X squared plus 12x plus 27. Notice that my graph crosses the x-axis right here at -9 and right here at -3. Therefore, those are my solutions: -9, -3. The next one, again, easy to solve by typing it into Desmos and seeing where it crosses. X squared minus 2x minus 63. Notice it crosses here at -7, and it also crosses at 9. -7 and 9. Let's do this one by factoring as well. I need factors of -63. That would be 1 and -63, 7 and -9. That's my winning combination. So I get x plus 7, x minus 9. Setting each of these equal to 0, I get x equals -7, or x equals 9, which are the same answers I got by graphing. This one would be more challenging to do as a factor, but it's not impossible. Numbers that multiply to give me 4 would be 1 and 4, 2 and 2. Numbers that add to give me 4 would be 2 and 2. So 4x over 2, 4x over 2, these both reduce to 2x over 1, which means I get 2x plus 1, 2x plus 1. If I set each equal to 0 and solve, well, I can just solve one of them because they're identical. 2x equals -1, so x equals -1/2. Typing this into Desmos to check, 4x squared plus 4x plus 1. You can see right here that it crosses at -1/2. It actually doesn't seem to cross, it touches, which means that's where the solution is. It's a double root. Solve by factoring. So I'm looking for two numbers that multiply to give me 45 and combine to give me 18. There's my winning combination. I can stop. So I'm going to say 5x over 3, 5x over 15, and reduce. Now this may be a different method than you learned for factoring, and that's okay. You can use your method, or perhaps you like this method. You can use this one too. There's many ways to factor. Setting each of these equal to 0 and solving, I have to set this left equation equal to 0 and the right equation. When I solve here, -3 equals 5x. -3/5 equals x. When I solve this equation, it's much simpler. X equals -3. says list the smaller answer first, so I'm going to put a -3 and a -3/5. Again, solve by factoring. What multiplies to give me 12? 1 and 12, 2 and 6, 3 and 4. Do any of these combine to give me 8? They do. 2 and 6. So I'm going to take my first term, write it twice, put the winning combination under it, and reduce. I can't reduce 2 and 3, but I can reduce 3 and 6. My factors are 3x plus 2, x plus 2. Setting them each equal to 0 and solving, I get x equals -2/3, x equals -2. Now they would like us to solve with the quadratic formula. Solving this quadratic formula, we need to state what a equals, b equals, and c equals. A, b, c. A is the coefficient of x squared, which is 1. B is the coefficient of the x term, and c is the constant. And my formula, -b plus or minus square root of b squared minus 4 times a times c all over 2a. I'm going to take out each letter one at a time and replace it with what it equals, -5. So I'm going to make that a -5, which makes that a positive. I'm going to put a -5 right here. I'm going to put a 1 right here. I'm going to put a -14 for C. And finally, a 1 for A on the bottom. Now let's simplify. 5 plus or minus 5 squared is 25. -4 times 1 times -14 gives me positive 56 rather. Over 2 times 1 is 2. 56 and 25 gives me 81. Radical 81 is just 9. So now we're at the point where we're ready to split. 5 plus 9 over 2, 5 minus 9 over 2. That gives me 14 over 2, which is 7. This gives me -4 over 2, which is -2. Those are my solutions, 7 and -2. Again, with the quadratic formula, A, B, C. A is 8, B is 1, C is -5. Substituting straight into my formula, -b plus or minus the square root of b squared minus 4 times A times C, all over 2 times 8, which is 16. Simplifying, I get -1 plus or minus the square root of 1. Let's see, that would be 20 times 8. 20 times 8 is 160 plus the 1 is 161 for 16. We're going to need to use our calculator to get the square root of 151. Notice that the answer says round to the nearest hundredth. So using my calculator, I'm going to type the square root of 161, which is 12.69. So I have 1 plus or minus 12.69 divided by 16. Again, I need to use my calculator for this. Negative 1 plus 12.69 divided by 16 gives me positive 0.73. And then we're going to type it again. Negative 1 subtract 12.69 divided by 16, negative 0.86. All right. Right here, negative 30. This point is a solution. Negative 2, negative 1 is a vertex. Negative 1, 0 is right here. That is a solution. And the parabola has a minimum because it's opening up. This point right here is the minimum because it's at the very bottom of the graph. This one asks us to use the add point tool to show the x-intercepts and the maximum or minimum. If I were to graph this, negative x squared plus 2x plus 3, I can see that it's going to open down, which I suspected because the leading coefficient was negative. I can easily see where the maximum is. It's right here. That's the 0.14. So on my assignment, I need to put a point at 1,4. That's the maximum. I also need the x-intercepts, where it crosses the x-axis. Well, it crosses at negative 1, 0 and 3, 0. So I need to add those to my graph. Negative 1, 0, 3, 0. And that's all I need to do for this problem. Okay, on this one we want to put these values on the graph to match what they are. The y-intercept is the first one. That would be right here where it crosses the y-axis. That's the y-intercept. The next one is a positive solution. Well, solutions are where they cross. So it's either of these points. Which one of these is the positive? This one. This is our positive solution. The negative solution is the other one. So on this side, on the left. And then the last one is the vertex, the lowest point of our parabola, where it changes from decreasing to increasing. What is the axis of symmetry of the parabola? Well, let's take a look at it graphically first. X minus 8 plus 2. Negative x minus 2 plus 8. That's what it looks like. The axis of symmetry is the invisible line that we can run right down the center of our graph right here and fold the parabola and it would line up on top of itself. So I can see that that's at x equals 2. X equals 2. Except I believe I typed this incorrectly. I did. I switched them. My apologies. Now you can see that x equals 8 is where the axis of symmetry would be. X equals 8. This graph opens down, which we knew even before we typed it in Desmos because of this negative symbol. That means it opens down. Alright, the axis of symmetry for each of these. Remember, the axis of symmetry can be found algebraically because it's going to be x equals negative b over 2a. If I take negative 6, that's positive 6, over 2 times 3, 6 over 6 is just 1. X equals 1. I could also type each one of these equations in Desmos and just look at the graph and see where the axis of symmetry is. Negative b over 2a is 0. X equals 0. Negative b over 2a gives me 3. X equals 3. Negative b over 2a is negative 2. X equals negative 2 is the axis of symmetry of that graph. Let's find the vertex. Let's do it algebraically. Negative b over 2a gives me negative 2 over 2, which is 1. Now I need to find f of 1. 1 squared minus 2 times 1 plus 3 gives me 1. Take away 2 is negative 1, and 3 is 2. 1, 2. Alright, we need to rearrange these so that the y-intercept is first. You can see right here that the y-intercept is 6, so that one's fine. Coordinates of the vertex. The vertex is the point 3, negative 5. So that needs to come next. Then it says, when is it increasing? This function, moving from left to right, is going uphill right here. From 3 to infinity. 3 to infinity. And then when is it decreasing? It's decreasing from negative infinity all the way until this point, 3. From negative infinity to 3. Alright, now let's talk about some transformations with our quadratics. If we add or subtract a number after the x squared, that's going to shift it up or down, respectively, to what the sign is. If it's positive, it goes up. If it's negative, it goes down. So we're looking for an answer that says shifted down 6. Right here, vertical shift 6 units down. Vertical shift 6 units down. When we add or subtract inside the parentheses before squaring it, that's when it's going to move left or right, and it's going to move the opposite of what you'd think. Since it's plus 6, we're looking for a horizontal shift left 6. Here it is. Horizontal shift 6 units left. Here we have a 6 before the x squared, but remember, addition is commutative, so we could say x squared plus 6. Now it's very similar to the first one. We're adding a number after x squared, which means a vertical shift 6 units up. And we've used all 3 of those. When we multiply x squared by a number, that's going to be a vertical stretch or a vertical compression. It's going to be a stretch if that number, that coefficient, is greater than 1. when we put a negative symbol in front of x, that's going to cause a reflection of the x-axis. And finally, when the coefficient is between 0 and 1, when the absolute value of it is between 0 and 1, that causes the vertical compression. Okay, we want to match the graphs in the first column with their corresponding functions. Here's the picture of our parent function. Remember that as we get to this one. Now we know that that graph that was right here at the center has moved 2 units to the right. How do we make it go 2 to the right? We subtract 2 inside the parentheses, which would be this one, g of x equals. Now you can see on the next one, I started at the center and I moved left 2 units. And we accomplished that by adding 2 inside the parentheses. So we've used that one, we've used that one. Alright, more transformation practice. Which one of these is the parent function? It doesn't have any numbers added or subtracted to it. It will be right here. That's our parent function. I like to start with that one, the parent function. Which one has gone right 1? Well, to move left and right, that's inside the parentheses. Which one has subtracted 1 and just subtracted 1? That's this one. This one has been shifted right 1. Which one has been shifted right 1 and up 1? That means there's a plus 1 after it. Right here. Shifted right 1 and up 1. Which one of the 2 remaining has been just shifted up 1? That means there's a plus 1 with no parentheses right here. And finally, shifted left 1 and up 1. And that was actually our lesson. We'll have a question and answer session. There's going to be a virtual one online as well as a face-to-face one, hopefully. And please stay tuned for more information about those forthcoming dates.